Hello, it's me, Adrian, PC hardware editor for Digital Reg with a quick video. Now let's think of this as a post-review update with some more musings on understanding memory modules. This will be the first of two videos detailing how memory modules are spec'd and tested. When picking PC memory or RAM, we'd normally just get the fastest possible speed that is available. With DDR5 memory having increased speeds, there is an incredibly wide selection of speeds to choose from. Also, how we measure memory speed is changing. The megahertz speed we usually see plastered over RAM packaging in previous generations is slowly being changed to megatransfers, which should be the proper term, as the use of megahertz only apply then to SD-RAM. With the introduction of double data rate memory or DDR, the data being passed by the CPU to the RAM is doubled, but not necessarily the frequency or speed in megahertz. Megahertz is simply the frequency or speed, and for DDR RAM, it is simply read as half of the rated megatransfer speed. This can be exemplified by a pendulum on older clocks or represented as a wave. Here's the wiki page of frequency, along with an animated GIF showing both a pendulum and a waveform when it swings over time. For SD-RAM, its data is passed for every tick of the clock only, or a swing to the left or right of the pendulum, not necessarily both ways. So in a wave, however, it would be the top or bottom peak. In DDR-RAM, it is counted twice on the left and right swings of the pendulum and both top and bottom peaks of the wave, hence the use of double in DDR. Now, what about certain builds requiring at least 2 sticks of RAM that makes it go fast? This is where confusion by some builders or users, especially newer ones, when setting up their PCs when throwing in their memories into the motherboard. Now, the term memory channels, it provides a number of paths for the data to pass through, like a road. While DDR have doubled the number of transfers, running on just a single lane, like a single lane in a road, can still be restrictive. Motherboards feature dual, triple, or quadruple memory channels to add in more lanes for data to pass through. So if we utilize 2 memory sticks on a dual memory setup for a typical motherboard, then we double the bandwidth for data to pass through. But with the recent review, I've begun to focus more on the latency aspect. It's one of the other features that make up a PC's memory specs. While megatransfers measure the amount of data transfers passed back and forth between the CPU and memory, and memory channel support in motherboards for memory bandwidth, latency needs to be considered very much more as well. But why does latency figure now more than, say, during the DDR2 or DDR3 generation? That will be for another episode.